Let's have a look at one application of completing the square. We have here a quadratic equation and we're asked to solve this, but we're asked to solve this by completing the square. So for some of you that probably might be thinking, oh, can't I just use the quadratic formula? In fact, it might be helpful to know that the quadratic formula is in fact a consequence of completing the square. So when you use or apply the quadratic formula, you're in fact applying a completion of the square, but it's kind of like you're using the end result of that. But we're going to do this manually. So let's have a look at solving this one here. 3x squared plus 4x minus 5 equals 0, and we're going to turn this into a perfect square and then use that to find a solution for x. Now this will have a solution. In fact, how would I know? Actually, we'll get to that maybe in another video, but this will most certainly will have a real solution. Okay, what we're going to do first, let's move the negative 5 over, adding 5 to both sides. So we got 3x squared plus 4x is equal to 5. Next thing we're going to do is we're going to turn this quadratic equation into a monic quadratic. So from a non-monic into a monic. Completing the square on a non-monic quadratic is definitely harder than for a monic one. In other words, where x squared is on its own. So let's divide everything through by 3. So 3x squared divided by 3 is just x squared, and that's very nice. 4x divided by 3 is just, 4 on 3x. I'll just leave the coefficient of x separate there. Is equal to 5 on 3. Okay, so we haven't changed the integrity or broken the integrity of this equation. Still holds true, the equal sign still happy. Okay, now let's complete the square on the left-hand side. So with a monic quadratic, very simple, you just take the middle term, so the coefficient of x, in other words, 4 on 3, we halve it. Okay, so half of 4 on 3 is just 4 on 6, which is just 2 on 3, and then we square it. So that's going to be 2 on 3 all squared. Okay, now I've left it in that form for a reason, in fact. Plus, again, that's 2 on 3 all squared. And in fact, I might just write it here in expanded form. So 2 on 3 all squared, 2 on 3 times 2 on 3 is 4 on 9. Okay, you'll see why I've done this in this way. Okay. Now we have a perfect square on the left-hand side. Again, that's very nice, and that's one of the reasons why completing the square is it's actually a very powerful strategy. So we have x plus 2 on 3, so we're going to factorize this expression, okay, or the left-hand side of the equation. So we have x plus 2 on 3 all squared. So it's something squared, when we'll get to the significance of this shortly. Okay, and 5 on 3 plus 4 on 9, well, you can combine the denominators. If you multiply top and bottom here by 3 on 3, we get 15 on 9, 15 plus 4, 19, so it's got 19 on 9. Okay, so a nice clean expression there. Now what we're going to do is take the square root of both sides. Okay, and this is why perfect squares are so special, and completing the square is such a powerful strategy. Square root of both sides. Okay, so take the square root of that. That is the inverse operation of squaring, and we're going to take the square root of this side too. And when you do that, it becomes plus, well, you get a plus or minus, sort of you get two solutions because we're taking the square root of a square. Okay, and that's sort of the only time at this point where you can sort of put plus or minus. If you know for a fact that it's positive under the square root, then there's no plus or minus, but we don't know that. The x plus 2 on 3 could in fact be negative, we're not sure. So that's why we get two solutions there. Alright, continuing on, x plus 2 on 3, okay, and that's equal to plus or minus. In fact, what I might do is I might just express the surd in the numerator, in the denominator, it's square root of 9, that's going to be 3, nice whole number there. Okay, doesn't have to be a surd. Now let's subtract 2 on 3 from both sides. So x is equal to negative 2 on 3 plus or minus square root of 19 on 3. And if we want to, we could split this up into two separate solutions instead of sort of expressing it in this way. Therefore, x is equal to negative 2 minus root 19 on 3, or x is equal to negative 2 plus root 19 on 3. And you can, in fact, use the quadratic formula to get the same result, and it would most certainly work. Okay, and you should get exactly the same result there. Thanks for watching.